Curvilinear coordinate systems 9 use the differential operator theorems to evaluate closed surface integral d sigma dot b using spherical coordinates, where S is the surface of a sphere of radius capital R centered at the origin, and v is, in part B, x cube ex hat plus y cube ey hat plus z cube ez hat. So we're doing part B now. Remember that we have to use Gauss theorem in order to evaluate this integral, and therefore we need the divergence of our vector v again, and in this case the divergence of vector v will be del x of x cube plus del y of y square, y cube plus del z of z cube, which will give us 3x squared plus 3y squared plus 3z squared. So 3 parentheses x squared plus y squared plus z squared. But in spherical coordinates, x squared plus y squared plus z squared is r squared. So this will be equal to 3r squared. Now we're ready to evaluate our integral. The volume integral d tau divergence of v will be the integral on r will be 0 to capital R, and now I have 3r squared, so let's keep this 3 here. R squared multiplied by my d tau r squared sine theta d tau dr. I'm going to get r to 4th power dr. So this is r to 4th power dr. The phi integral is 0 to 2 pi d phi, and then I have the theta integral 0 to pi sine theta d theta again. So I'm going to get from the r integral capital R to 5 over 5. So 3 over 5 capital R to the 5th power. The phi integral will give me 2 pi, and the theta integral will give me minus cosine theta, which is to be evaluated between 0 and pi, which is another factor of 2 again. So my final answer for the closed surface integral d sigma dot v will be a factor of 2 here, 4 times 3, 12. 12 pi capital R to the 5th power divided by 5. This will be the answer to part B. Okay, so since I've already done part A, I know what d tau is in spherical coordinates, r squared sine theta, dr d theta d phi, and the divergence of v gave me another factor of 3r squared. So r squared becomes r to 4th power, the volume integral 0 to capital R to 4th power dr. Then the azimuthal angle I have to change from 0 to 2 pi, polar angle from 0 to pi to cover the full spherical volume. And the corresponding integrals will have d phi and sine theta d theta in them. These integrals are fairly simple, so I obtain 3 over 5 capital R to 5 minus 0. So it's capital R to 5 over 5. And this integral gives me 2 pi, and this integral gives me a factor of 2. The final answer is 12 over 5 pi capital R to the 5th power.